In fact, this title is explaining what this topic about. It is the language of physics. So the keyword here is the language. So language is used to communicate. So people communicate with each other with this language. So English is a language, so we can talk with each other and express our feelings. So physics, if the title is language of physics, which means there must be a language physics uses, or in physics we use to communicate to or to express the facts in the physics. That language is mathematics. So physics physics uses that mathematics as a language to express the quantities or the measurements in physics. So physics generally does observations. So when these observations can be but simple observations, or we can also make some measurements by using measuring instruments. So measurements are also a kind of observations. So when we do this measurements, we want to know what is the relation between physical quantities. So right here, generally, the data or informations are collected about at least two physical quantities. So we are going to collect information at least about two physical quantities. So one of the simple example is, for example, the classroom temperature. So is increased as time passes. Right here we have, if we make some observation, how we for time we need a chronometer or clock. We need a clock for temperature. So to measure the temperature of the classroom, we need a thermometer. So when we use these two devices, so clock measures the time, thermometer measures the temperature, so we can collect data about the temperature and time. So these two are physical quantities. So which means we are going to collect some information or about these two physical quantities, how they are changing. So right here we say that time and temperature are variables, and I'm going to get some data about time and temperature, and I'm going to try to find the relationship between the time and temperature. So as time passes, how the temperature of the classroom changes. To do that, of course, you are going to start your thermometer and clock at the same time. So you are going to get data. For example, at time is equal to 0, you will calculate. Say that at when you start your clock at time is equal to 0, assumes that the classroom has a temperature of 22 degrees Celsius. And then you are going to start measuring the following time. For example, you cannot measure always or any second or any minute. For the first time is 0. Second one is, for example, if when the time 5 minutes passes, you measure the second temperature. For example, assume that it is 22.5 degrees you read from the thermometer. So later you are going to measure 5 minutes later and another temperatures. When it's 10 minutes, when it makes the clock shows 10 minutes, so you are going to measure another temperature, which is 20, for example, say that 23 degrees Celsius. Go on when the time when time is equal to 15 minutes. So when 15 minutes passes, you are going to measure, for example, say that 23.5 degrees Celsius, and go on. When time is equal to 20 minutes passes, assume that you measured a temperature which is equal to 24 degree Celsius. So now, to observe or to get the exact relation between these two data, the best way is, the first method is to construct a table. So in this table there will be variables. So two variables are here, or we say these variables are as physical quantities. Physical quantities. So we are going to make a table about these two quantities. One quantity was the time, so we are going to make a column for time. Second quantity was the temperature, and we are going to record the temperature on the following column. So time is measured in minutes, so temperature is measured in degrees Celsius. So when time is equal to 0, so we recorded the temperature of the classroom as 22 degrees Celsius. After 5 minutes, when time is measured 5 minutes or 5 minutes passes, assume that you measured the temperature of this classroom as 22.5 degrees Celsius. When time, the clock shows 10 minutes, temperature of the classroom is 23 degrees Celsius. So when the time is 15 minutes, classroom temperature is 23.5 degrees Celsius. When the temperature is, the clock shows 20 minutes, temperature is 24 degrees Celsius. So when you look at the table, so you are going to see a clear trend between time and temperature. As time passes, temperature of the classroom increases, so you can get it. Even you can calculate that the temperature increases every 5 minutes by 0.5 degrees. So this is another information you can read from this table. So to get the relationship between these two quantities, the best way, and one of the best way, is to construct a table. So this is the first way we are going to obtain to get the relationship between two physical quantities which is measured. Next way is to draw a table from this, to draw a graph from this table. So second best way is to draw or to construct a graph. So like what? For example, right here we have two physical quantities. One of them is time, the other one is temperature. So I'm going to locate temperature on the vertical axis of this graph and time in the horizontal axis. So this is generally the best way of, when we are drawing a table. So time always in horizontal, other quantity always in vertical. So temperature of the room or the classroom, which is in degrees Celsius, and we are going to measure the time by clock in minutes. So we will start with 0. Later, 5 minutes later, according to this table, we measured the temperature. 10 minutes later, again we measured the temperature. 15 minutes later, once again we measured the temperature, and finally at 20th minute we also measured temperature. So when time is equal to 0, temperature was 22 degrees Celsius. But when time is equal to 5 minutes, we measured a temperature which is 22.5 degrees. So this is the first point. This is the second point. Go on. When time is equal to 10 minutes, so we measure the temperature which is 23 degrees Celsius. So then on the coordinate system on the graph show the next point. After that we measured when time is equal to 15 minutes, we measured a temperature which is equal to 23.5 degrees Celsius. So it is in and the next point. And right after that, when finally when time is equal to 20 minutes, we measure the temperature, which is 24 degrees Celsius. This is the last point. So when we check these points, we observe that this, or we see that these points all are located on a line. So when we connect these points, we will see that a line. This line is the graph which gives information about how temperature and changes by time in that classroom. So from this graph, we provide more visible relationship between these variables, between these two variables. Another thing is another advantage which this table give us is to make some estimations for the times when we have no data. For example, we measured or we take data only 5th, 10th, 15th and 20th minute. But what about the time between these two, for example, in 12th minute? So we didn't make a calculation, but by using this graph, we can calculate, we can make estimations what was the temperature when time shows 12 minutes. So by this method, we are able to find, of course we should use a graphic table, we can read the all temperature when time is equal to 12 minutes. Also, you can predict temperature after 20 minutes. So for example, when time is 30 minutes, so you can also draw a line to this graph and you can get the corresponding temperatures from this graph. So graph also, as you see, help us to predict or to estimate the values which is not recorded by the measuring instruments.